Hello everyone, this is Professor Maloney and today we're going to start Chapter 6. Chapter 6 is using user-defined functions and procedures. User-defined functions in programming are used to help us organize our programs in a better fashion. You know, I've been talking for the last couple chapters about how, hey, you know, the first two chapters in the class, we just did everything basically from A through Z. You know, we started at the beginning and we went to the end, and then in chapters 4 and 5 we started doing repetition, where we got to pick now that, so we have choices if we use if statements, or we use selection structures, or we use do loops, do while loops, or while loops, or for loops. We can take different paths in our program depending on what we're trying to do. And now in Chapter 6, we're going to start putting a little bit of that together in a different fashion, and that being to also say that we don't have to have everything just done in one function. You know, because int main is a function, and it's called a void function, a void, V-O-I-D function. And void functions don't have to have a return. They're just functions where you can just kind of do things. But we're going to, in this video, and then in Chapter 6, we're going to start doing some coding where we have functions, and functions are done so that we can do our code, like I said, differently. Like as an example, if you have a program that as part of it does some calculations on taxes or something, you could literally have just a function called taxes or calculate taxes, and then you can call that taxes function from your main and do it outside of main in a function, and then return a value, meaning return the answer that we're looking for from that tax calculation back to the main procedure. Okay, so that's what we're really going to be doing in Chapter 6. But there's a lot to it, right? So let me just pull up, well, let me actually just share my screen. Yeah, share screen. I hope you guys are doing well. I hope you're doing well. So we're in Chapter 6. My gosh, time flies, right? All right, so I've got, let's see here. Am I sharing my screen yet? I don't think I am. Yeah, I am. Of course I am. Yes. And I've got my audio on. I've got my video, well, capturing my screen capture. All right, so over here, I'm going to go up to the book. Let me just go do it again. Let's, I don't think it's in the right. Let me just do that. Do that. No, it is there, I guess. Oh, well, let me just think. All right, I got my PowerPoints. That's what I wanted to actually start with, my PowerPoints. So slideshow from beginning. All right, so let's see here. Did I verify that I'm recording? Sorry about that. I got to do it again because I don't like to then get messed up. You're recording. All right. Okay, so Chapter 6, Maloney. Sorry about me being a little bit thing. I may have to have a piece of candy or something. Anyway. All right. So, yeah, PowerPoint slides. PowerPoint slides, and I got my ebook over there. I already opened up my ebook. I might want to just go back to the very beginning of Chapter 6. Why won't it? Let me get out of it and then open it. Okay, there we go. So let's go to the beginning of Chapter 6. All right. Okay, so now I've got that open, and I'm going to open up my PowerPoint and then run my PowerPoint. So function 5. Okay, so PowerPoint. In this chapter, we're going to learn about standard functions and discover how to use them in a program. I mean, we've been using predefined functions for a while. Like when we did the pow function, that's the power function, you know, like 2 cubed or 3 squared or 4 to the power of 10. You know, that's using the power function, and we've done that. Anytime we're using some of those libraries with, like especially the C math library, where we have so many things, you can do square roots, you can do the floor, you can do the ceiling, you can do the power. There's lots of things we can do with math using that particular library. So they're called predefined functions. So think about just one of them. Let's say, again, the power function. What is the power function? Well, it's the POW, P-O-W is short for power, but POW, open parenthesis, x comma y, right? So open parenthesis, x comma y. It means there are two required arguments, and by default in the predefined function, it's just x and y, but x and y we know are going to turn to numbers. So if you want to build a little program that was just you getting to test yourself, playing games, or just having fun with your friends, just showing, the POW function, you can put in any two numbers, and then if you want to really practice and play, you can get pretty good at it, right? So it's a pre-built function. It only does that one thing. One thing. So we're going to be doing functions that do one thing or two things or whatever in this particular thing, but with what we call user-defined functions. User-defined functions mean we create it, okay? We will create it. When you create user-defined functions, you have some choices, basically. If we create a value returning function, okay, value returning functions, the value returning function means it's going to return a value to what we call the calling procedure. So let's sort of organize ourselves here a little bit. And it's best to organize ourselves in this regard by actually showing. So what I'm going to do is just pretend I have a program up here. I actually have it up on my ebook. And my ebook, well, sorry, my physical book. I got the physical book. So it's on page 376, okay? So what I'm going to do is cut that for a second, minimize that for a little while, and go to page 376, okay? Now, 376, why is my book always different? I don't know, mine has a different page. Okay, largest number, yeah, here. Okay, so in this programming example, the function larger is used to determine the largest number from a set of numbers. For the purpose of illustration, this program determines the largest number from a set of 10 numbers. So 10 numbers, all right? You can easily enhance this program to accommodate any set of numbers. Of course we could, that's no problem, right? But we're going to create this as a function is what they're going to ask us to do. So here's our data. 10, 56, 73, 42, 22, 67, 88, 26, 62, and 11. But you imagine you enter any 10 number. That doesn't matter, all right? So read the first number of the data set. That would be 10, okay? So what they're telling us to do is that because you only read one number, well, that's the largest number, right? 10 is the largest. Okay, fine. So you're going to assign it to a variable called max, all right? And again, this is, I say you're going to, or we're going to, or I'm going to, doesn't matter. But this, I'm just reading, basically, to help us understand what this particular program will do. So we read the first number, we assign it to max. Then we read the second number, and we call it, or assign it to num. So now we got max, and we got num. Now we compare max and num. Is max greater than num? Okay, that type thing, right? So read the second number called num. Now we want to compare max and num and store the larger number into max. So if num greater than max, num greater than max, then we want to assign num to max. Num equals, max equals num at that point, right? So, and that would be an assignment, so 1 equals sign. So we store the larger number into max. Now max contains the larger of the first two, so 10 and 56. So 56 is obviously the bigger. So 56 is in max. Now we're going to compare 56 and 73. Well, now 73 is the larger, so we want to make sure it's in max. Then 73 against 42. 73 is still larger. 73 against 22. It's still larger. 73 against 67, it's still larger. 73 against 88, 88's now larger. 88 against 26, 88's larger. 88 against 62, 88's larger. 88 against 11, 88 would then be max at the end of the program. So that's what this program is going to do. So now let's just see more or less what they're saying. So read the third number, right? I just sort of walked through this, but so read the third number, that's right here. Compare it with max and store the larger number into max. At this point, max contains the largest of the first three numbers. Read the next number. Compare it with max. Store the larger into max. Repeat this and repeat and repeat and repeat until we go through all 10 numbers and always storing the largest number in max. Okay? All right. So read the first number because this is the only number you've read so far. It's the largest number so far. Save it in a variable called max. Did. Now, for each remaining number in the list, read the next number, store it in a variable called num, compare num and max. If max is less than num, then num is the new largest number, so update the value of max by copying num into max. If max is greater than or equal to num, discard num, that is, do nothing with it, because max now contains the largest number. All right, so here is the program. But I want to talk to you about everything on the program, so I want to make sure that hopefully my screen with this full book is large enough. Let's see what I can do up here. If it's that one, if I can make it larger, let's see, that. Yeah, I think it's getting larger. All right, so let me go there. And now let me go here. Okay, so hopefully that's a little bit larger now. Okay, although I could probably bring this over now. Let's see, full book, because I don't need the other page. Let me just make it this way. Okay, and now let's make it larger still. Let's see. Okay, there we go. Now we're talking. All right, so here's the program. Now, up here, we're just using our normal pound include. We're using our usual namespace standard. So, but you see something different up top now. This is a user-defined function, and this line specifically, is called a function prototype. Okay, it's a function prototype. So, double is the data type, obviously, that we're using. Larger is the name of the function prototype. Okay, it has 2 required arguments, and by the way, it could have 10, it could have 1, it could have 3, but this is what they've done. So this one they created. It's going to have a value returned of double. Okay, it's called larger. It has 2 required arguments. They sometimes call these parameters, but double x, so that's another double data type, comma, double y, that's another double data type, and then close the parentheses, and a function prototype ends in a semicolon, just like a code statement. Okay, but the important thing is, look, it's above int main, so you need to remember this. When we declare when we have user-defined functions, we declare a function prototype. Okay, and the function prototype is exactly this right here. All right. Then in int main, we're going to be calling this function, but technically we're calling the function definition, which is down here, but I'll come back to this momentarily. So the function prototype is here, right? This is where int main goes when it finds something in the program that it doesn't recognize. Like right here, max equals larger, open parenthesis, max comma num, close parenthesis. So larger is this program, this part of the program right here, this function. Okay, so when the program goes through here and gets down to max equals larger, the program is searching. C++, the compiler is searching for larger, the program. It finds it. Okay, yeah, double larger. It's got 2 arguments, x and y. They're both double data type. Comes down here. Larger, okay, max and num. Well, max is going to be a number that we're getting from reading it from either a file or from a person. So let's see, here we're saying for count equals 1, count less than 10. So we're just doing a simple for loop. Okay, the user though is going to enter num. Okay, so the user is going to enter num, and then we're going to say max equals the larger of max or num. All right, so let's see where we have the values. We have double for num, variable to hold the current number. Double for max, variable to hold the larger number. Int for count, to obviously count up our counter as we're going. And we're always going to, the number they return is always the user gives us. It's called num, right? Then we're saying Max equals the larger of either max or num. But see, this is a function. It's calling it. So first thing it does is now it says, well, let's see. It's not looking for max. That's an assignment statement. It's looking for this on the right of the equal sign. Larger, comma, open parenthesis, max, comma, num, close. And here it is. Larger, open, double, that's the data type. Variable is x. Double the next data type, comma, of course, to distinguish. There are two required arguments. Another double data type and another variable name. So x and y are both double variables, okay? So when we have this statement down here, it needs to have two arguments. So they're calling their arguments max and num, okay? Order matters in this programming world. X is going to take the first number. So whatever is in max is going to be x. Whatever is in num is going to be y, okay? And we're assigning the larger of those two to max. Max may already be the larger, yes, but it may not be. Whichever of these two is larger is going to go to max. But you might say, yeah, but my God, there's no code. How do I know what larger? What is larger? Oh, well, that's the function prototype up here telling us it's returning a double data type. The name of the function is larger. It has two arguments, both also double data types. So then what it's doing is it says, now where is my larger? Where is my function? Oh, here it is. So the function definition is here. So up here, it's a function prototype. Function prototype. Up here, we're calling the function. And here is the function definition where the work is done. So when we get to this point here, larger up. So again, we're in a loop, right? So the user's entering 10 numbers. We're assigning each of those to num, and then we're going to compare num to max, okay? So max initially is num, right? Max equals num. So the user tells us, let's say the number, well, let's say exactly the numbers we saw up, where is that? We had numbers up here. There. We'll say the user enters 10 and then they enter 56. I'll remember 2. Okay. So 10 and 56. So first number, 10. 10 is assigned to max. Max is our variable, which is going to represent the larger number. Because 10 is the first number that the user entered, it has to be assigned to max. There's only one number. What's bigger than 10? Well, there's only one number, 10. So 10 is the bigger. Okay, so max equals the larger of max or num. Since num was assigned to it, it's now 10, but that's only on count 1. Okay, so the larger number is 10 because 10 is in max. Comes up here. Now the user enters the second one, which I think I said was 56. 56. Okay, so then 56 comes down. That's the C input for number 56. Then num equals, max equals num, all right? So we already have that number 10. I'm sorry, I apologize. This was from the first one, silly me. All right, so here's my loop. Here's where I'm at in my loop. The first one was 10. So 10 was the num. We assigned it over to max, but from this larger max and num. Okay, so how do we do the larger max and num? Well, it takes two numbers to have the comparison done. So the first one is 10. We have that value. We need to go into our larger to see what's going to happen next. So here it's double x, double y, and double is that it has to be down here. This is the function definition. It must be exactly the same as the function prototype. This one again, remember, is called the prototype. So when the numbers are being read in our loop, we're going to be calling them every time it hits this. Max equals the larger of max, comma, num. So now we have max because that was done from this first value. So we have max. We have num coming in for the next value. So we're comparing 10 to 56. So down here in the function definition is where we determine what's what. So the first one is 10. The second one is 56. Remember we said it's based on up here. So the first one is we'll just say the variable x and then y. So, excuse me. But we're putting them for max and num. So max we're assigning arbitrarily to x variable, and num we're assigning to y variable. Each time when we're looking, that's the way those numbers are assigned. So it's going to be 10 and 56. 56 is bigger than 10, so now num is going to be that one, okay, based on this. If x is the first one, greater than y. In this case, it's not, because 10 is less than 56. So we're doing the else, because it was false, return y. So 56 goes up here, gets the third number, which is whatever, 10 or something. No, 73. So now 73 will be larger, right? So we got 73 and we got 56. So it's going to go through, it's going to go through, it's going to go through. But the point is, you've done this before, right? I mean, we've done for loops. Well, we only did for loops really starting last class, but we did while loops for the class before that. So we've been doing loops now for a week, and we've done the if statement logic. We're not using if statement logic here, but anyway, so you've done this. You know that a for loop has three required elements, and there's 2 semicolons in it. The first one is called the initial value. The second one is just called your the condition. You're doing something up until count is less than 10. So meaning up until the number 9. You're incrementing the counter. That's count plus plus. And then you're taking the value they give us, and then you're comparing that number there against the other number, which we have as max. And then either num or max will be the new larger, assign it to max, and then we go back up again and go up here again and again until we get the values that we're looking for. So it'll go through all 10 numbers comparing 1 against 2. Then the larger of 1 and 2 against 3. Then the larger of 2 and 3 against 4. Then the larger of 3 and 4 against 5. Then the larger of 4 and 5 against number 6, meaning the numbers up here, okay? So we're going through all these, and then what it amounts to is we've compared 2 numbers. This is the larger. 2 numbers, this is the larger. 2 numbers, this is still the larger. 2 numbers, this is still the larger. 2 numbers, this is still the larger. 2 numbers, this and this. This is now the larger. 2 numbers, this is the larger. 2 numbers, this and this. This is the larger. 2 numbers, this and this. This is the larger. So this is the larger out of all those 10 numbers. And our computer could do it in 2 seconds, even if we have 100 numbers, even if we have 1,000 numbers, right? So we could do that. So what I want you to understand is, and I'm going to be doing demonstrations, obviously, on the next 2 class days, although one of those class days I'm going to be in Chicago, if you remember, on Thursday, October 28th. So on that day, you're going to have a video to watch, and I'll just send a course announcement when it's prepared, but it'll probably be the Wednesday evening, because I leave for Chicago at like 5 o'clock in the morning on Thursday, the 28th. And I come back, by the way, the 30th in the evening. So it's only for 3 days. But anyway, so you'll miss me for 1 day. All right. So we have a function prototype. The function prototype has exactly the same header as the function itself, the function definition. This has to be exactly the same, but in the function definition, there's no semicolon. Okay. The function definition is like an expression, just like ifs, just like else ifs, just like while ifs, just like whiles, just like switches, and just like case statements within switches, all of them. So no semicolon at the end, but on the function prototype, yes, you do have a definition. This is just the defining prototype, not the code itself. So anyway, but this part from double, larger, open, double space, x comma, double space, y, close. That part is exactly the same as here. But down here, then we have an opening curly and a closing curly, and that's where we put the code, okay? The only thing it's doing is figuring out which number is larger of those 2 numbers, all right? And then it has to be called. So number 1 thing is we first start with a function prototype. We type that in just above int main. Then we type the definition after end main. We type the definition for exactly the same function prototype, but now it's called the function definition. It doesn't have a semicolon on the header line, but it's got an opening and closing curly, and there it's got the code to figure out which is the new larger number. So it's going to either return X or Y each time. Each time it's going to go through it, and it's always the larger that's assigned to max, and then we're just comparing max as the X, and the num as the y until we again get larger. So when you see x and y here, all you have to figure out is the first one is called x, the second one is called y. That's comparing up here, up here to double x and y, so they're the same. And then here in the main, where it's calling it as larger, open, max, and num. Okay, see, these don't have to be the same names as x, y, but what happens is max is arbitrarily, or it's automatically called the x. It's the first value. Num is the second, so therefore it's y. So when the user types in the numbers, and we have a max and we have a num, then they go down here to larger, the same order. So this max is going in here, and this num is going in here, and then it's comparing, is x or max or num or y the larger? And then it figures that out from here, and then it returns the value right in here, returns the larger value here. So even though this says max equals larger, max, and num, when it goes here to larger, max, num, then it gets the answer, okay? And the answer is returned, comes down to the largest number is max. So here's where it returns one number out of these two. It returns 1, which is the max. Then it goes up to do the 4 for the next iteration, and it keeps doing it until it finishes, obviously, all 10. All right? So now, why would we do this here when we can just have it in the main? Well, that there's no right or wrong answer. But remember, programs normally are pretty big. Again, all of our programs in this class have been pretty small, although there are some in each chapter really that are like 3 or 4 pages of code. I haven't shown you them, and maybe I'll do one of them or show you it just to show you a bigger one. But anyway, the point is just that functions allow us to have our code organized a little bit better where it's not all in main. Because when you're looking at a program like here, we see, oh, double larger, and it's all by itself down here. Then there could be another, something else, and another something else, and another something else. They would all require a function prototype up top, and you would have to call that prototype. And the call doesn't mean you don't use the data type, so you don't use that in the call. You call it with this name here and the same number of arguments, but the arguments could be different. Like this could be larger, open, 1, 2, if you had a variable and you named it 1 and you named another variable 2, or answer 1, and answer 2. Whatever it is, that doesn't matter. But larger here doesn't have to refer to double x, double y, and it doesn't have to have the data type. It doesn't have the data type. Actually, not that it doesn't have to. Doesn't. You don't put it on it. So larger, it verifies. Yeah, I got a function prototype called larger. Does it have 2 arguments? Oh, yes, 2 arguments. Are they both doubles? Oh, yeah. Well, again, if someone typed them in as whole numbers, its whole numbers work as double. So up here, we're assigning them as double, okay? And then we come to the function definition where the work is done. And when it hits this return y here, okay, or return x here, whichever one is the larger, then it returns that to the function name again. So, oh, sorry, here. Right here. It goes back to main. So the return always comes here. So then it's either max or num, but either one, the answer is max because we're looking for the bigger. So the number comes here, and then the largest number is, and then we start to count to the next one. Comes down here again. When it hits larger with its 2 variables, comes down here again. Puts the first variable in x, the second in y. Is x greater than or equal to y? And you might say, why is it greater than? Why not just x? Well, if the 2 numbers are 10 and 10, it doesn't matter which one you assign. The bottom line is both are right. So in this case, we're just saying they're saying, they did this program, if x is greater than or equal to y, meaning if this one is greater than or equal to this one, meaning if this one is greater than or equal to this one, they're all the same as long as you do the right order, then when we say return x or return y, whichever one is being returned comes back to just the next line of code from here. So here's where we are at with larger, max, num, and we put the number in max. Okay, and then we do it again. So that's all it's doing. So this is a very good example. See page 376 here is where it is in the book. All right, let's go back to my PowerPoint. All right, and so learn about standard. I talked about that enough. User-defined functions. I just said this is an example of a user-defined function. Okay. Now, value returning functions. That means it returns a value. It has to have that return statement. So if I go back over to, where was I? That was in here. Yeah, in here. So it has to, a value returning function has to have a return statement anywhere that it can, like any value that can be invoked. In other words, this is either true or this is true. One of these is true. So if this one's false, then this one's true. If this one's true, then this one's false. But they're both doing return is the point. This one returns the first value. This one returns the second value. Whichever one is greater is the answer. But you have to have a return statement. This is the return statement. Okay, this is the return statement. And it gets sent to the next line of code after this, because this has been done. The larger open, max, common, num, close, that was done down here. So here was the call. It went up to see the function prototype. It exists. It verifies it's got the right number of arguments. And then this, the prototype, comes down with it, what it got from the for loop, and puts it into the function definition, first one and second one again. And then it does its little tiny question. Is if x is greater than or equal to y, return x. If it's not, then return y. X or y is returned up here. And now max is either x or y, whichever one was greater. Or in the case of x, greater or equal. Okay, and then we do that. So understand, again, function prototype looks like this. Okay, you call it, when you're calling it, it looks like this. And normally it's an assignment statement. You know, you're taking one or the other and assigning it over. So usually, doesn't have to be, but usually assignment statements are where the function is being called in int main, if it's a value returning function, because we want to get a value. We don't want 2, we now want 1. We want the answer to this number and this number based on this formula. Which one is larger? Okay. So function definition, function definition here. We're calling the function here, and the function prototype is where we define the function up here. Not define it, sorry, where we state that we have a function that we're using. All right. Okay, that is that. So let's go back to PowerPoint again. Now there's a whole bunch of these, oh, by the way, in here, and this is much more important than the slideshow, but I'll be doing one of these, obviously, as I mentioned, in the next class. So here's void functions. I'll just, while I'm here, talk about void functions. Now this one I want to make a bit smaller because that's kind of too big now. Maybe that may be too small, I don't know. Anyway, so yeah, let me make it here bigger. Here bigger than that. All right, so earlier in this chapter you learned about value returning functions. This is now 20 pages into the chapter, by the way. Okay, this chapter is like 90 pages. Okay, 90 pages, but a whole bunch of examples, a whole bunch of information on this stuff. What I cover in the next 2 class days, meaning after this video, excuse me, the chapter 6 overview, then that's the focus for what you need to be prepared to do on an exam. And I'm going to have at least one, well, I mean, my 2 programming things, I'll probably have a challenge or 2 or 3 on each of them. But for one of them, I'll say, okay, this particular programming exercise that I demonstrate doing, programming example that I end up doing in class, either this coming Thursday or the next Tuesday, I'll say, sorry, this Tuesday, next Tuesday, or the following Thursday. One of them, I'll say to you, if you get it correct with with the test deck that I put out there for the challenge, I'll say that you can then pick any program from 6.1 to 6.6, any one program, and I'll give you 100 points on it. And you don't need to officially do it as long as you do my challenge, right? Same thing. Okay, but I'm still not done. So a void function, main is actually a void function, just to let you know, because it doesn't have to return a value. But a void function is different than a value returning function, because the value returning function, again, must return a value. Okay, they have a similar structure though. Void functions have a heading and a body, but they also have the function prototype, which they're not defining yet, but maybe when I read it, it will. But I've already said everything that needs to be said, but I'm going to read this just to make sure they're giving us what you need. So void functions and value returning functions have similar structures. Yes, they're exactly the same, but there's no return statement in value returning. Sorry, there's no return statement in a void function. So like value returning functions, you can place user-defined. User-defined are things we create. So user-defined void functions either before or after the function main. I don't know what they're talking about here. You must put a function prototype before function main. You may not need to put the function definition under int main, but if that's what they're saying, okay. But I know that's what I always do. Function prototype above int main, function definition below int main. And remember, the function definition is where you have the code, and you have to call it within int main. A void function does not have a data type. Okay, like int main, technically, there's nothing in there calling the int, like there's no argument, so therefore it doesn't have a data type that does anything, is what that really means. Okay, doesn't have a return type. All right, however, in a void function statement, but without any value, there's nothing, like as an example, in int main, we have a return. It's really return, open, 0, close. That is a return, but it's by default, so we don't need to officially call it. But that's an example actually of a void. So you can have void for int main, doesn't need to do anything. By default, it will return an empty return, which just basically means the program's over. Okay. So anyway, now here where they start with function definition, it's going to be, I don't really like to look at it from this perspective for you guys, because I like you to see things that are actually the code or what you're going to do. That example there that I said from page 376 on the other was real good. So I think that makes good sense for us. When we're talking about the void functions, there's also some examples in the book, but I don't want to go there right now on any of that. And I'm not going to talk too much today, because these are not, I mean, even though I'm still on slide 1 or slide 2, but you know, again, as always, I tell you, I cover things while I'm on it. So user-defined functions, that's what I just defined, and I just demonstrated how that program on page 3, I forget what I said now, page 376 maybe. Let me minimize again. Yeah, well, it was 376, but then I hit the greater than, and I don't think this thing moves numbers. No, it doesn't move the numbers, see? So 376, though, is where I was. So page 376, if you go there, you're going to see that value returning larger function, the larger function, which was good, okay? All right, so now back to PowerPoint. Okay, so value returning functions have actual and formal parameters. The formal parameters are, let me again go back here, because it's all, that's where it is where I can explain things. So actual and formal, actual and formal, actual and formal. So let me go back here, excuse me. Okay, so here is formal parameters, double X, double Y. In the function prototype, they're formal parameters. In the function definition, they're formal parameters. Actual parameters, and I don't really like the term parameters. Remember, arguments. Arguments is what they are, okay? But where it's called here, larger with max and num, these are actual. In other words, these are the numbers we're inputting from the user. So down here, these are not formal. Formal just means it has the data type, it has the variable name, it has the other data type, the other variable name. It's got the value for the whole function, meaning you have to return it as a double. We could have had an int here and an int here, but still return it as double, okay? Right? As long as you know what you're doing and it is numeric, then you could do that. But anyway, so these are formal parameters, formal. Down here, these are actual, where it's max and num, they're actual, okay? Again, go back, sorry. All right. Explore how to construct and use a value returning user-defined function in a program. We just covered this beautifully with that example of larger, okay? Learn about function prototypes. I just showed you exactly where the function prototype is right here as well. This is the function prototype. Beautifully, you understand it. It's the same as the definition, but the definition doesn't have a semicolon, but in terms of the data type, in terms of the function name, in terms of the formal arguments, okay, or parameters. It's all the same as the function prototype. Just remember, function prototype is above int main, function definition is under it, and the function definition has the opening and closing curly with the code, okay? And the other one has actual, not formal parameters, okay, or formal arguments. It has actual, meaning the ones that the users are giving us, or we're reading from a tape, or we're reading from a text file, or whatever we're doing, okay? All right, so that's that. So again, see, we're able to move on even though there's 100 pages. Sorry, I'm just a little whatever today. Okay, so that was that. And then I just told you function prototypes. And now I said how to construct and use void functions. Okay, so now I would like to show you a void function, but I'm not going to be going through all my PowerPoint for it. I'm going to just go over to my book. This is my book. And I'm just going to go until I see a void function similar to how I found that larger one. Let's see, that may have been one. Reference variables as parameters. I'll talk about that. But see, I can talk about everything but that gets tough. There's a lot. Okay, here we go. All right, so here we have, I don't know what page I'm on now. It's the bad thing. How the heck do I find out my page number? Why the god darn? Doesn't it? See if there's a footer on this silly thing. Come on, come on, come on, come on, come on. I don't see a page number. Well, make the assumption. Let me find it in my book. I've got my book here. I just don't like to do this, so I don't like to waste time. Anyway, if you're going through the power of the ebook, right? If you're going through the ebook, you'll see it here where it says reference variables as parameters. This is an important section. It may be 8 or 10 pages because this chapter has so many pages. But anyway, so let me just go to this calculate grade first to show you what they've got here. So they're talking about a program to take a course score, a value between 0 and 100, and determine a student's course grade. This program has 3 functions. It's got a main function. Well, we've been using the main function forever. A get score and a print grade function. Okay, so main is getting the course grade and printing the course grade. This is what we're getting from the user. And then we're doing obviously something in a function, so we're going to then do some printout after, okay? The get score is a void function, and this one is probably a void function, but where we're using a, how do they phrase it? Reference variables. So there's reference variables and value variables. Reference variables can change the value from the memory location, which actually gets passed in reference variables in C++. It's not something that we really have to worry about, but when you hear about these things, you know, where a company was hacked, a bank was hacked, you know, a credit card company was hacked, whatever, and people hacked. Normally, it's from really sharp hackers that can go in and find spaces in programs where data actually resides, and it's called like memory locations. If you have a reference variable, technically that reference variable is passed as part of the argument or the parameter, and if it's a value variable, all it does is it takes a copy instead of a actual reference to the real location. So then when it passes a copy, that I'm talking about a value variable, passes a copy, then the value variable is safe because it doesn't know where the memory location for that information is. A reference variable passes the actual address, so it's dangerous, but it's only dangerous again in when you know a website is not handling what it needs to handle correctly. All right, so for now, just understand reference variables can give the memory location of a variable. And if it does that, then that means it can also accept a change in that value of a reference variable, not value variable, but reference variable. So therefore, somebody could potentially make a change where a number goes way higher or way lower, depending on what they want to do with it. So it's dangerous, okay? So that's those two. But reference parameters are useful in 3 situations. So when the value of the actual parameter does need to be changed, then yeah, you need a reference parameter. Otherwise, you can't change it when it's a copy. When you want to return more than one value from a function, okay, because a return statement can only return one value, but if you have a reference variable, the reference variable has a memory location, so then you could have another value go to. When passing the address would save memory space and time relative to copying a large amount of data. Okay, so that's when you might want to use it. The first 2 situations are illustrated throughout this book, chapters 8 and 10. 8 we'll be doing, we won't be doing 10, of course. Chapter 8 is the highest we go. 8 and 10 discuss the third situation when arrays and classes are introduced, okay? So 2 and 3, and we'll only be doing 3 in chapter 8, all right? So that's that. You can declare a reference parameter as a constant by using, well, I mean, const is obviously, we all know that. Right. So anyway, in this example, I'll just kind of go through it and see what they have. But this one's going to be a void, I think. So I want to make sure I have it. So they have 2 void function prototypes. Okay. Now, you see there's a get score and a void print grade. The void get score, if you look real carefully, it's an open parenthesis, int, and then the ampersand. Remember I say the ampersand is an and clause. So the ampersand is that thing above number 7 on the numeric keypad on the top of the, not the number keypad on the right of the keyboard, but the top where it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 0, and above number 7 is an ampersand. But this ampersand here means it's a reference variable. So get score can change the value, okay? And the logic for in this particular one is that obviously the program is not just going to get one thing at a time. It's going to be going through some kind of a loop to get scores. And so therefore it has to change the score at the original memory location. So int with an ampersand means it's a reference variable. That's what that means. So this function here is a void, yeah, but it's using a reference, okay? The one under it is using a value variable instead of a reference. So int is, there's no ampersand. So up here where it's int ampersand is not a mistake. That is what they're doing, and that's on purpose, okay? And we'll have probably an example where we're doing that. So then down here, you see void get score. Again, it's int ampersand score. Now remember, here is the function prototype. Why is it the function prototype? There's 2 of them up here. Well, here's int main. If it's above int main, it's a prototype. Prototype is just where it's not really defined, but where it's like where the variable, if you want to just call it, the variable is set up, okay? So void get score, int ampersand score, and then close the parentheses. That has to be exactly the same as in the function definition. So let's go down now to under. Here's int main. Int main ends here. Here's the void get score. So it's the same. Void, again, get score. And by the way, void, remember the other one had double and then the name of the function and the name of the function up here. But with void, remember there's no data type because you're not returning anything. So it doesn't matter. Here you say, well, because that's the number we're using, the one variable we're using in it, but we're not, here's where it gets returned. If this had a data type, that's what, when it's a value returning function, the data type that's on the left of the function name, that's the one where it's getting the return from. So here, void means it's not being returned. Anyway, int ampersand, then you look down here, int ampersand, score, score. So it's exactly the same, just like I said. Now there's also, though, a void print grade with just an int and a score. So that means there's a second function. See down here, there's another function. And again, it's under int main. Return 0 ends int main, basically. Well, the closing curly, sorry, ends it, but you always just look for the return 0 in most programs. A lot of times I don't use it because by default it's in there as return 0, just to let you know. Anyway, all right, so void print grade has to also be the same. So void print grade, open, parenthesis, int space score close, no ampersand. Void print grade, open, int space. Here it's C score. I don't know what the C score is, but that part's okay to change. This is something though about what they're returning. So C score, score. Maybe just to let you know that you don't technically have to have the exact name here, as long as it's a formal parameter, and it's formal by having the data type and this thing here. Maybe we'll see C score as I read, but I honestly don't know what that is doing there. But either way, it's okay. And then the definition has where the code is, right? So here, the code, here, the code. Okay, let's go in and look. So it's C score. Let's just see if I see that. Okay, so what this one's doing actually is comparing a value, because one is a value and one's a reference. This one is a reference, the get score. The print grade is a value. So the value can't return, can't change the value, can't change the underlying address. The get score, because of the ampersand, can. So that's the one where they're probably going to make a change. So int, whatever I just said, and that was, where were they? So print grade doesn't have the ability to make any change, okay, because this is only posting the grade for the number that is going, but it's not changing. It's a copy, okay. So let's see where they have all these values telling us what's happened. Well, be sure to read this, okay? We're not going to do much with voids, but it's possible to be on the test, and obviously if it is, then you're going to get an example from me when it's the practice exam day, which would be the Thursday before the Tuesday exam. So, but read this for sure. It's important, okay? But I think I've covered it well. All right, so that's there. Go back to my PowerPoint again. So we talked about function prototypes. We understand void functions, and we just now saw an example. It's exactly like a value returning function. The function prototype is the same name. There's no data type though where the word void is. Whereas on a user defined, instead of void, it's going to be data type and then the function name. Here it's going to be void and the function name, okay? And then it's still called from the main procedure, meaning int main, and the function definition is still underneath int main after the closing curly brace on int main. So that we've done, covered. So even though this is literally 40 or more pages, probably actually 50 or 60 pages just for this, there's 30 some odd pages on value returning functions, okay? And quite a few examples. And I'll probably end up using one of those examples and just modify it and come up with a challenge, for you guys on a thing or two or three that I want you to also get from it, all right? Excuse me. Okay, so then the difference between value and reference parameters, that's what I was just covering there. So what's a value parameter? The value parameter is a copy. It takes a copy of the value. That's all it does. A reference parameter gets a copy of the parameter, but also the memory address, which means conceivably the value could change. So value parameter it cannot, but reference parameter it can change, and sometimes we need them to change though, right? As you just saw in those two examples on the previous slide for something on grades. One of them was a int ampersand, and I said the ampersand means it's a reference variable or reference parameter, or reference argument, and that just means that it can come back and change. And obviously, like if a student gets an 85, you want to go back and put that in his or her file, so the memory location from the reference would allow the update to go back to that location to replace what was there before. That's what it means. Okay, explore reference parameters and value returning functions. So that's what I just, that's this part. So again, parameters mean it can change. Value returning, it's just a copy, it can't change. Learn about the scope of an identifier. Now, scope of an identifier is also very, very important. What this is talking about is in our programs, and let me again find a program so I can show you that. Where are we? Program in here. Okay, I'm just going to look for another program. Actually, I'll look for where they talk about that. It's going to be coming up relatively soon. So I've talked about reference parameters and value. I mean, you'll see the headings in whether I've talked about it. Here, scope of an identifier. So identifier in this context means like the variable, okay? In every program we've done thus far, we've just had variables declared in int main before we used the variable. Meaning, if we had a variable named double number 1, okay, then before we could use number 1, we had to declare it, right? But it's called a local identifier, meaning it was only good in the main function, okay? And once the program used it and left that spot, then it was, and if it comes back into it again, that was either replaced by the new number that's being input, or it was not used again, but it goes when the program is moving. The program moves out of that particular area, then it's gone. So local identifier, the variable is what we call automatic. And automatic means it uses it when it's read in a local procedure, and once it's finished with that procedure, it's discarded. Okay, that's what that means. So local has the least scope, all right? A global identifier or global variable is declared outside of everything else. It would be declared up top again above int main, and it would be good in every function you had in your program. Okay, if you had different classes though, it'd only be good within one class, but there's another way to make them in, like if you got 3 or 4 CPP files, a global would be good for one CPP file as long as it's declared up top. Local is only good within one procedure. But there's another one, I don't remember the name, but it's usable if you have multiple CPP files in one program, okay? But global is like the boss, if you will, okay? All right, now, so I did that. Let's go over, still looking for what I wanted to find. Global variables. So here, okay, so here's actually an example. Where am I at time-wise? 440 something. I think I started this one maybe at about 4, so I'm going to have to wind it down soon. But there's good examples in here. So let me just kind of read and see what this thing is saying. So global variable, pound include IO stream using namespace standards. See, they've got this int t up here above int main and above the function fun1. And this is I should ask you guys, int ampersand a. Remember, the ampersand means it is a reference parameter. This is the parameter or argument, okay, which means that it conceivably could change the value of int a back in the memory location where it's stored, okay? If it didn't have the ampersand, it would be a value, meaning a copy argument, okay? Okay, so anyway, t though is declared there. So down here, t equals 15. And t equals whatever. If we make a change to t, it would then change, is what it means. Up here, t is 15. At some point, they're probably going to change t, and they're going to want you to know that that change, because it's declared as a global variable, then replaces the other one. But if it's just all within int main, then, and here it was declared, so let's say we had int t equals 15 here, or just int t, and then we put t equals 15 later, but still within this particular function, the main function, then it wouldn't be able to change outside of that function afterwards, okay? Now this one, so we got now a main, we got the fun1. The fun1 was the one up here. This is the one that may change, so it's got the int ampersand again. And t equals, you know, instead of me going, I'm just going to, go, I'm going to, let's read if they have it. So let's see, line 8 in main, t equals 15. Line 8, t equals, of course it's 15. It's right down here, right? Yeah, so line 6 or 7 declares it, and line t, yeah, it's 15. We know. All right, so that, fine. Whoops. Now let's go. In fun1, a equals 15, and t equals 15. I thought we were only looking at t. Okay, there's an a as well. So in fun1, in this one, they're 15 as well. Or the one we looked at, it's still 1500. So T here is 15, all right? I'm only looking at T. I'm not going to worry about A at this point, all right? All right, so then in line 17, though, in Fund 1, T is now 27. So let's see what happens there in line 17. Line 17, in Fund 1, A equals A and T equals T. Why is A here? What happened here? So in Fund 1, A equals that A, and T equals T. Why? There's 15. We had that value 15. Somewhere in here they're adding 12 to it. What happened? Let's see. I didn't want to keep going because I've got to try to finish and wrap up, but this is simple. So what's going on? Oh, A plus 12 right here. Okay. Yeah, so A equals A plus 12. So here it's 15, and 15 and 12 is 27. Okay. And then we're also saying that T equals T. T equals T plus 13 is after it. So let's see, 17, Fund 1, A is 27 and T is 27. Why is T though? Because A, I didn't see T change. T equals T, and T equals 15. T equals T, 15. T equals T, 15. Then okay, here it's called though. Okay, that's what's going on. Okay, so here, Fund 1 T, remember, then it goes into Fund 1. So in Fund 1, T is A equals A and T equals T. So it is still 15 here, but it's not done now. Yeah, and now T changes, okay? So here, A equals A plus 12, line 17 in Fund, A equals whatever, and T equals T, okay? So that was 15, but now it's T equals T plus 13. We're still in Fund 1, and then in Fund 1, A equals whatever and T equals whatever. So then we're getting this, and it goes back to Fund 1 there. So it's not always just looking at the line, but the point was whether it's changing or not. And because T is a global variable, the value at the end changes, okay? So T equals now 40, 27, and 13. I still missed, there's a line somewhere where I'm not seeing where it changed it. But anyway, the reason T is changing is because of the reference variable. A is only in Fund 1. That's why A is changing. T changes because it's like here, a local variable for A, because it's all in Fund 1, will change. But here, because T came from the global variable, which was declared above int main, it changed this way. It's different than the other one. Okay, I know it may not make sense, but I promise it does. So anyway, and then I got to just keep going over static and automatic variables. So static variables are like global variables. That means they don't change. Automatic is, I think I said automatic a few minutes ago. Automatic variables are local variables where they get the values based on the declarations, the assignment statements, and they get the values based on any calculation changes that make changes. But once the program ends, or once a different function is called, then the automatic variables go away. Okay, so that's what that means. Again, read it though, okay? All right, we got to keep going. Debugging using drivers and stubs. We won't be doing drivers and stubs in this class, okay? In this class, but I'll just show you basically what they're talking about with stubs. So let me kind of read and see. So in this and previous, you learned how to write functions, yada, yada, yada. Combine functions, yada, yada, yada. Program may contain a number of functions. Yes, complex program, usually when a function is written, it's tested and debugged alone. Yes, you can write a separate program to test the function. The program to test the function is called a driver. For example, the program in C in 6.15 contains functions to convert length from feet and inches to meters and centimeters and vice versa. Before writing the complete program, you could write separate driver programs to make sure that each function is working properly. So the driver program is basically designed to just show your values. It's similar to just putting little COOT statements with values in periodic places in a program so that you can test the output before you finalize your program, all right? So in here, let's see if they were telling us anything again. So in this sample run, the user input is shaded. So they're putting in 30, 15, and 10. Enter the rate of the water. The user is putting in 100, and then the time to fill. So this is doing calculations based on 2 or 3 different functions. 1, to, well, probably, actually the calculation is probably only based on these two, pool capacity and pool fill time. The other one, they're just doing a print based on what the values are, okay? So anyway, but that's all that thing is doing. And a function stub, they mentioned, is a function that is not fully coded. For a void function, a function stub might consist of only a function header and an empty set of braces. So basically it means it's something that you might modify later on, but technically, like a return, I mean, int main doesn't have any required arguments too, because it is void. So in here, though, it's the curly braces, and it would be empty, similar to every time you make an int main, you have an opening, closing curly brace. Parenthesis. Here it's curly brace, parenthesis, but nothing's in it. So a function stub seems similar in that regard, but I don't know. I don't use stubs. So, and it won't be in the class. So, all right. So that function overloading is also not going to be done in this class. Okay, but basically it's when you have more than one function with a similar name and you can overload the function. So it's complicated, and we're not going to be doing that in our introductory class. So this is the very end of chapter 6. So I think I'll be ending, but you won't have this on a test. So functions with default parameters, this is not needed till chapter 10. So this is where we're basically over, and then there's the review. Okay. So basically, we are done with our Chapter 6 overview. I apologize for if it was a little bit boring. Again, I don't really like these kind of overviews, but I think I was able to pull out of it what you need to know, especially about the value returning functions and what a function prototype is, what a function definition is, and when and where we call our functions. So there's 3 things with a function. Function prototype, that's above int main. A function definition, that's below int main. The function prototype and the function definition both have what we call formal arguments or formal parameters. That means it includes the data type and the variable name for the data type, okay, in both of those locations. When you call, then it uses what we call actual parameters, not the formal. And the actual just means like where it passed num and it passed max or something. Those are just the values, because where the user is entering information, he or she, the user, they wouldn't know what a formal parameter is. So in their case, they're just putting in the numbers, and we plug those numbers into the formal parameters. Okay, so that's that. We went through value returning functions. We described void functions. We talked about the formal parameters, and I just talked about it just again right there. That's in the function heading, and the function heading is what a function prototype is, and the function heading in a function definition is again the same thing. It's the first line. Okay. Actual parameters are from the calls, meaning it's come from where the user is inputting the information. Right. To call a function, use its name together with the actual parameter list. That just means like when we call something. So in that int main, we had a call to, I forget now what the program was called, larger? Was it called larger? And we had to have larger and an open parenthesis, and we had to have the right number of arguments. But that's all we had to put in it. Okay, and that is that. We talked about return statements are required with value functions, and conceivably you can have more than one return statement, but when you do, you're using reference parameters, reference values. That's the ones that have a ampersand after the data type. Okay, so that's all good. That's good. So just read the rest of that stuff. This is, the closing part of the chapter. So I'm going to shut that down right there. I'm going to come over here. Have a great day, and I'll see you in class.